Here is the improved script in English, ready to use. Carl Sagan once said something that stayed with me for a long time. He said the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. And it is a beautiful thing to say. But here is what he did not tell you. When you are cremated, when your body is placed inside that chamber and heated to nearly 2,000 degrees Fahrenheit, not a single atom of that star stuff is destroyed. Not one. The pattern dissolves. You disappear. But every atom continues. Every single one. And what happens to those atoms, where they go, what they become, in those 2 or 3 hours inside that chamber, that is what I want to tell you about today. This is not an abstract idea about the afterlife or souls or anything like that. This is physics. This is the first law of thermodynamics, which states plainly that matter and energy cannot be created or destroyed, only transformed. And cremation is one of the most dramatic transformations your body will ever undergo. It is the moment the pattern called you ceases to exist. But the atoms that made you scatter into the winds, and each one of them has a story about what happens next. To understand where your atoms go, you first need to understand what you are actually made of. At the atomic level, the human body contains approximately 7 times 10 to the 27th power atoms. That is 7 octillion atoms. 7 followed by 27 zeros, a number that is almost impossible to hold in the mind. And those atoms are not distributed evenly across different elements. Your body has a very specific recipe. 65% of your mass is oxygen, not the oxygen gas you breathe, but oxygen atoms bonded into water and into every organic molecule that keeps you functioning. 18% is carbon, the backbone of every organic molecule in your body. 10% is hydrogen, mostly in water, but also in fats and proteins and DNA. 3% is nitrogen, primarily in your proteins and your DNA. 1.5% is calcium, almost all of it in your bones and teeth. 1% is phosphorus, mostly in bones but also in ATP, the molecule your cells use for energy. And then there are trace amounts of sulfur, potassium, sodium, chlorine, magnesium, iron, and a handful of others. That is the complete list. 7 octillion atoms arranged in one very specific pattern, and somehow that pattern is conscious and can wonder about itself. Now here is what happens when your body enters that cremation chamber. The temperature rises to between 1400 and 1800 degrees Fahrenheit, between 760 and 980 degrees Celsius. And that temperature is not arbitrary. It needs to be hot enough to break the molecular bonds holding your body together, but not so intense that it vaporizes everything. Different chemical bonds require different amounts of energy to break. A carbon-to-carbon bond, the kind that forms the backbone of organic molecules, takes around 3000 degrees Celsius to break completely. Cremation does not reach that temperature. It does not need to, because what cremation does is break the bonds between molecules, not the internal bonds within the atoms themselves. And this distinction is everything. The moment the temperature begins to rise, the water begins to leave. Remember that 65% of your mass is oxygen, and most of that oxygen is bonded into water molecules. Each water molecule is 2 hydrogen atoms and 1 oxygen atom. At cremation temperatures, water transforms into vapor almost instantly. All the water in your blood, in your cells, in your tissues, vaporizes and becomes gas. That gas, that steam, rises through the chimney and enters the atmosphere. Those hydrogen and oxygen atoms that were part of you, that were in your blood just hours before, are now water vapor in the air. Some will condense into clouds, some will fall as rain, some will be absorbed by plants, some will be breathed in by other people. But they continue. They do not disappear. As the temperature climbs higher, something else begins to happen. The organic molecules in your body, the fats, the proteins, the DNA, the carbohydrates, start to break apart. And what are organic molecules made of? Carbon. Long chains of carbon atoms, with hydrogen, oxygen, and nitrogen bonded to them. When those molecules break apart in the presence of oxygen and heat, they combust. They burn. The carbon atoms combine with oxygen atoms from the surrounding air to form carbon dioxide, CO2. And just like the water vapor, the carbon dioxide rises and exits through the chimney. This is where the carbon of your body goes. The carbon that was in your DNA and your proteins and the fat that cushioned your organs. All of it becomes CO2 entering the atmosphere. And that carbon will be absorbed by plants during photosynthesis. It will become part of a tree or grass or a flower. It will be inhaled by animals. It will dissolve into the ocean. It will continue cycling through the carbon cycle of the earth for millions of years. The carbon atoms that were once in your body will be inside thousands, millions, billions of other living things across time. They do not stop being useful. They simply stop being you. The nitrogen in your body, primarily in your proteins and DNA, also becomes gas. At cremation temperatures, nitrogen bonds break and nitrogen gas, N2, is released. Nitrogen gas makes up 78% of Earth's atmosphere. So those nitrogen atoms simply rejoin the vast reservoir of nitrogen in the air. Eventually, they will be fixed by bacteria and soil and become part of plants, then animals, and perhaps another human being. The nitrogen that was in your DNA, coding for every trait you had, may one day be in someone else's DNA, coding for characteristics you will never know. But here is where it gets interesting. Not everything becomes gas. Some atoms in your body have far stronger bonds that do not break at cremation temperatures. Calcium and phosphorus, the minerals in your bones and teeth, remain solid. They do not vaporize. They do not combust. What happens instead is that all the organic material surrounding them burns away, and what you are left with is bone mineral, primarily calcium phosphate, along with small amounts of other minerals. This is what people call cremated remains, ashes. They are not really ashes in the way we usually think of them. They are bone fragments ground into powder. And that powder, those cremated remains, weighs between 4 and 8 pounds for an average adult. Think about that for a moment. You start with a body that weighs, say, 150 pounds. After cremation, what remains is 4 to 8 pounds. Where did the other 142 to 146 pounds go? Into the air, as gas, as water vapor and carbon dioxide and nitrogen gas. The vast majority of your mass leaves the cremation chamber as invisible gas and disperses into the atmosphere. Only the dense mineral structure of your bones remains. Now, you might wonder why calcium stays solid when carbon becomes gas. The answer has to do with the type of bonds involved. Carbon, when it is part of organic molecules, is held together by covalent bonds with other carbon atoms, with hydrogen, with oxygen. These bonds are relatively easy to break with heat. But the calcium in your bones is not in the form of simple molecules. It is in the form of calcium phosphate crystals, an ionic lattice structure that is extraordinarily stable. To break those bonds, to turn calcium into gas, you would need temperatures around 5,000 degrees Fahrenheit or higher. Cremation does not reach those temperatures, so the calcium remains solid. And here is one more thing worth knowing. The calcium in your bones, the phosphorus, those atoms are ancient. They were formed in the cores of stars billions of years before the Earth existed. They were part of the dust cloud that collapsed to form our solar system. They were in the primitive Earth, cycling through rocks and oceans and living things for billions of years before they became part of you. And now, after cremation, they sit in an urn, still solid, still the same atoms they have always been. And one day, if those remains are scattered or buried or dissolved, those calcium atoms will become part of the Earth again. They will be absorbed by plants, by animals, by future humans. They do not end. They simply change form. This is what the first law of thermodynamics tells us. Matter and energy cannot be created or destroyed, only transformed. And that is exactly what cremation is. A transformation. The arrangement of atoms that was your body has been disassembled. The pattern is destroyed. But the atoms themselves continue, every single one. The physicist Richard Feynman reflected deeply on atoms and what they mean. He spoke about how the atoms in your body right now are not the same atoms that were in your body 7 years ago. Your body is constantly absorbing new atoms from food, water, and air, and constantly releasing old atoms through waste, breath, and sweat. The pattern remains roughly the same, but the atoms are always changing. He said that the atoms making up everything we see, including our own bodies, have already been in stars. And now I am telling you that after cremation, those atoms will be in other things. Other stars? No. But other trees, other animals, other people, yes. The universe wastes nothing. Every atom is conserved. Every atom continues. The pattern that was you, the arrangement of those atoms that gave rise to your thoughts and memories and personality, that is gone. But the atoms themselves are immortal in a certain sense. They have existed for billions of years, and they will continue to exist for billions more. Now, let us be precise about the numbers, because the numbers make this real. An average adult body contains about 7 times 10 to the 27th power atoms. After cremation, the water vapor released contains approximately 65% of that mass. So, roughly 4.5 times 10 to the 27th power hydrogen and oxygen atoms enter the atmosphere as vapor. The carbon dioxide released contains about 18% of your original mass. Approximately 1.26 times 10 to the 27th power carbon and oxygen atoms. The nitrogen gas contains about 3%, roughly 2.1 times 10 to the 26th power nitrogen atoms. And the cremated remains, the bone ash, contains about 1.5% calcium, 1% phosphorus, and trace amounts of other elements, totaling around 3 to 4 times 10 to the 26th power atoms. Do the math. All 7 octillion atoms are accounted for. None are missing. None are destroyed. They are simply in different places in different forms. And here is something worth knowing. Crematoria have filtration systems to capture some of the particles and gases. But they cannot capture water vapor. They cannot capture carbon dioxide or nitrogen gas. These molecules are too small, too light. They pass through the filters and exit into the atmosphere. So when a person is cremated, their carbon atoms, their hydrogen, oxygen, and nitrogen atoms, they spread. They mix with the air. Within days, some of those atoms will have traveled hundreds of miles on the wind. Within weeks, they will be spread across the region. Within months, across the continent. Within years, everywhere. And this applies to everyone who has ever been cremated. The atoms of every body ever cremated in history are still out there, cycling through the environment. Some of them are inside you right now. You have breathed in atoms that were once part of people who lived 100 years ago. You have drunk water containing atoms that were once in the bodies of ancient humans. And one day, atoms that are in your body at this moment will be part of another person. They will inhale you, drink you, eat you, with no idea that those atoms were once part of a person who lived in the 21st century. Now here is where people get confused. They say, well, if the atoms continue, does that mean I continue? And the answer is no. You are not your atoms. You are the pattern, the arrangement, the specific configuration of those atoms that gives rise to your consciousness and your identity. When that pattern is destroyed, you are gone. The atoms are just atoms. They carry no memory of being you. They do not carry your thoughts or your personality. They are simply matter, following the laws of physics, moving through the environment the way atoms have always moved. Think of it this way. A book is not the paper and ink. It is the arrangement of ink on the page, the pattern that encodes information and meaning. If you burn a book, the paper and ink still exist, transformed into ash and gas. But the book, the pattern, the story, that is gone. Cremation is the same. The atoms remain. The pattern does not. And what does death mean at the atomic level? From the perspective of physics, nothing actually dies. Atoms do not die. They simply rearrange. A living body is a highly organized system with atoms arranged in very specific patterns that are maintained through metabolism and cellular repair. Death occurs when that self-maintenance stops. The patterns begin to break down. Deterioration begins. And cremation is simply an accelerated version of that breakdown. Instead of taking weeks or months or years for bacteria to dismantle your body, cremation does it in 2 to 3 hours with heat. But the end result is the same. The atoms that were in a highly organized living system become part of the less organized environment. The carbon becomes CO2. The hydrogen and oxygen become water. The nitrogen becomes nitrogen gas. The calcium becomes mineral dust. And the second law of thermodynamics, which states that entropy, disorder, always increases in a closed system, is satisfied. Your body, which was a low entropy, highly organized system, has become high entropy, disorganized atoms spread across the environment. And that is how the universe works. Everything that is organized eventually becomes disorganized. Every pattern eventually dissolves. Stars burn out. Mountains erode. Living things age and stop functioning. And all of it is simply atoms rearranging according to the laws of physics. The atoms in your body have been part of countless other things before they became part of you. The carbon atoms in your body may have once been in a dinosaur, or in a tree that grew during the time of the Roman Empire, or in the ocean, or in the atmosphere, or in rock deep underground. Those atoms have been cycling through the earth for billions of years, becoming part of living things, then non-living things, then living things again, and they will continue doing that long after you are gone. There is a calculation that produces a striking thought experiment. If you take the number of atoms in a human body, about 7 times 10 to the 27th power, and compare it to the number of atoms in the atmosphere, about 10 to the 44th power, and you assume those atoms mix completely over time, then statistically, every breath you take contains a few atoms that were once inside Julius Caesar or Cleopatra or any historical figure you can name. And the same will be true for you. 100 years from now, 1,000 years from now. Your atoms will be in other people, and they will not know it. They will inhale you, drink you, eat you, with no awareness that those atoms once formed a person who lived in the 21st century. The temperature required to actually destroy atoms, to break them down into their constituent particles, is not the temperature of cremation. It is not even the temperature at the surface of the sun. To disintegrate a nucleus, to split an atom into protons and neutrons and electrons, you need temperatures on the order of millions or billions of degrees, the kind of temperatures that exist in the cores of stars or in nuclear explosions. Cremation reaches, at most, 1,800 degrees Fahrenheit. That is nothing compared to what it would take to actually destroy an atom. So when I say that not a single atom is destroyed during cremation, I mean that literally. The atoms are exactly the same after cremation as they were before. Same number of protons, same number of neutrons, same number of electrons. The only thing that changes is how they bond to other atoms. The molecules break apart, the atoms remain. So where do your atoms go after cremation? Into the air, mostly. Into the water cycle, into the carbon cycle, into the nitrogen cycle, into plants and animals, and soil and oceans. Some remain together as bone ash for a time, but eventually even those will disperse. They will dissolve in rain, or be scattered by wind, or be broken down by geological processes. And over time, across centuries and millennia, those atoms will spread across the surface of the planet. They will become part of everything. And this is not exclusive to cremation. If you are buried, the same thing happens, only more slowly. Bacteria decompose your body, and the atoms are released into the soil. They are absorbed by plant roots. They become part of trees and grass. They are eaten by animals. They enter the water table. They evaporate and enter the atmosphere. The only difference between cremation and burial is the speed and immediacy. Cremation releases your atoms into the atmosphere in hours. Burial releases them into the soil over years, but the final result is the same. The atoms continue. And here's the point. You cannot stop this. You cannot preserve atoms forever in the form they are in right now. Even if you tried to seal a body in a perfectly airtight container, eventually those atoms would escape. The container would corrode. The seals would fail. Geological processes would tear it apart. The atoms always find their way back into the cycle, because that is what atoms do. They move, they change form, they bond and unbond and bond again. They have been doing this for billions of years, and they will continue doing it for billions more. So if you take one thing from this, take this. You are not permanent, but your atoms are. The pattern that is you, your thoughts, your memories, your consciousness that is fragile and temporary. But the atoms that make you up, they are as close to eternal as anything in this universe. They were here before you. They will be here after you. And right now, for this brief moment, they are arranged in a pattern that can think about itself, that can wonder about where atoms go after cremation, that can appreciate the strangeness and the beauty of being a temporary arrangement of stardust. And when the time comes, when your body is placed in that chamber and heated to nearly 2,000 degrees, those atoms will be released. The carbon will become CO2 and feed the plants. The hydrogen and oxygen will become water vapor and fall as rain. The nitrogen will return to the atmosphere. The calcium will remain as dust. And all of it, all 7 octillion atoms, will continue their journey through the universe exactly as they have been doing for billions of years, exactly as they will do for billions more. That is where your atoms go. That is what happens. And I find that to be a kind of immortality, not the kind people usually hope for, but the only kind the universe actually offers. The atoms continue, the pattern does not. And somehow, knowing that, understanding that, makes the pattern feel more precious, because it is so temporary, because it will not last. Because right now, in this moment, the universe has organized itself in such a way that it can know itself, can think about itself, can understand the laws that govern it. And that is beautiful. That is how it works. That is science.